What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. If you have 100 feet of fencing, what rectangular dimensions will maximize the area contained? Hit that pause button and see if you can figure it out. When you're ready, hit play, and I'll give you the explanation. So of course there's a way to do this algebraically, right? What you can do is you can draw out a rectangle and we can assign variables to the side lengths based on this perimeter, right? We have 100 feet going all the way around. So therefore we could call this side X. We could call the other side X right here. And then what are these other two remaining sides? Well, they are 100 minus 2X, right? We have 100 total minus 2X divided by 2, cut in half. So this would be 50 minus X and 50 minus X. Now we have representations of those side lengths. The area is just this times this, and then we try and maximize it, etc. Okay, so that is of course the algebraic way to approach this, but a better way to go about this, because they love asking about this in math class all the time, is to recognize one thing. If you're creating a rectangular shape to maximize area with a set perimeter, the shape that will do it every time perfectly is a square. So when you have a square, right, you're just basically taking 100, dividing it by 4, and you got 25 by 25. The area for this is 25 times 25, which is 625. Now I'm going to show you why you can't get an area bigger than 625 feet squared. So let's just take the little example of, let's modify this side and make it a little bit smaller to 24. Let's modify this side and make it 26. So now with this little modification, we can multiply 24 times 26 as follows. 4 times 6 is 24, carry the 2. 8 plus 2 is 10, 0. 2 times 6 is 12, carry the 1. 2 times 2 is 4, plus 1 is 5. And we've got 4, 2, 6. So we've got 624. So you can already see that this is dropped by 1 square foot. Now we'll move it down further, right? We got 100 feet. Another possibility is we could have 20 by 30. Multiply those two together. 20 times 30 is 600. That's a more substantial drop. So as you can see, as the side lengths get farther apart, right, as we go all the way down, 49, 49, 1, and 1, right, we could have a really long, skinny rectangle. That would only have an area of 1 by 49, which is 49. So you can see the farther apart they get, the smaller the area, the closer together, the larger area, which means that when we're trying to find a shape that maximizes the area for a rectangle, it's going to be a square. So rewinding everything, we are back to dimensions of 25 feet by 25 feet, which makes a square. That's how you do it. Done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining. See you in the next video. Take it easy.